Okay, ladies and gentlemen, you are welcome. So, in today's tutorial, we are going to answer questions in physical chemistry. And please, don't forget that if this is the first time you come to my YouTube channel, please try to subscribe and join the YouTube membership so that you can have access to exclusive hacks. So now, first question that we are going to look at is that question one says, what is the expression for Kc for the reversible reaction at equilibrium? And we have the equation here where hydrogen fluorides react with water to produce hydroxonium ion plus fluoride ion. So, and we have the following options. Option A, Kc is equal to concentration of hydroxonium ion times concentration of fluoride ion divided by concentration of HF. Kc for option B, hydroxonium ion concentration, fluoride concentration divided by the concentration of hydrogen fluoride times water. Kc that is for option C is HF concentration, water concentration divided by hydroxonium ion concentration times fluoride concentration. Kc for D, hydrogen fluoride concentration divided by hydroxonium ion concentration and fluoride ion. So these are the options. So what is going to be the answer? It's simple. I think we need to look at the chemical equilibrium first so that you will have a general idea of what it is. So what is equilibrium? And a chemical equilibrium is a state where the concentration of the reactant and product are equal. So if you have a reaction where the concentration of reactants is equal to have the equal concentration with that of the products, remember, this is a reaction. And we have reactant and we have product. So whenever you have the concentration of the reactant is equal to the concentration of the reactant, so the product, it tells you that that reaction is in the state of chemical equilibrium. Let's say you have 1 molar concentration here, and you also have 1 molar concentration. So as we can see, the concentration of reactant and product here is 1 molar. So it means that there is an equal concentration. So that tells you that the reaction is at equilibrium. But very importantly, ladies and gentlemen, in a chemical equilibrium, remember we have different types of reaction. So a chemical equilibrium is usually represented with a reversible reaction. So this is a reversible reaction because it has a double-headed arrow. It has a double-headed arrow. So this is indicating the forward reaction. This is indicating the reverse reaction. Sometimes the reaction that is in chemical equilibrium, sometimes the concentration may be altered. Maybe when the concentration of the reactant is decreased, then it means that the product will now favor more of the reactant formation so that's to balance the equilibrium states. So that is why it is in reversible reaction. The reaction can proceed both in forward and in the reverse direction. So let's see, now you have, in this case, let's say you have the reaction now. Let's say you increase the reactions of the product, let's say from 1 molar to, let's say 1.05 molar. And remember here is 1 molar. So what will happen? This reactant will now, this product will now react or will now favor reactant formation. So the product will now move in the reverse direction so that to produce more of the reactant in order to balance the equilibrium states. So that is why in chemical equilibrium, we use a reversible reaction. And very importantly, ladies and gentlemen, we have even a law or a theory called Lichard principle, Lichard principle. They're trying to show how when a reactant or product concentration is altered, that will now lead to the change of the reaction so that to restore the state of the chemical equilibrium. So very importantly, ladies and gentlemen, in a chemical equilibrium, we have what you call equilibrium constant. That is Kc. And the Kc is called equilibrium constant, which is trying to show the ratio of the concentration of product, the ratio of the concentration of product products divided by the concentration of the reactants. So this is how to express chemical equilibrium. But very importantly, we should know that in expressing this chemical equilibrium, there are some very important information. If in your reactant you have your liquids and solids, so the liquid and the solids will be excluded in the expression. Let's get this very important information. If in your reaction equation you have a pure solid or a pure liquid, so at that point you have to exclude the solid and the liquid in the expression. So that's what I want you to understand. Like for example, now let's look at this equation. This is a pure liquid, water. So it has to be excluded when we are going to express this. So how are we going to express this, ladies and gentlemen? Let's use this. You see, this is the product. So we have to start. So in chemistry, whenever you see, this is Kc. So in chemistry, whenever you see this, it means this bracket, it means you have a concentration. So this bracket means concentration. So therefore now we have hydroxonium ion times concentration of the fluoride ion divided by the concentration of HF. Because this is liquid, so it's usually excluded. So therefore you are not going to use it in your expression. Because so whenever you have a pure liquid or solid in a chemical reactions and you are going to express Kc, so usually they are excluded. So that is why here we exclude water molecule. So therefore, as we can see clearly for this equation, this is how to express the Kc. And look at our option. As you can see, the option A is the correct one. So therefore, A is correct. And all the other three options, B, C, and D, it appears wrong. I hope you understand, ladies and gentlemen. And I want to also add one very important information. So what if you reach a state where you have a larger Kc value? Let's say now because with the Kc value, it will tell you whether the reaction is at equilibrium or is not at equilibrium. So now, how do you do that? If you have Kc, if your Kc value is large, what does that mean? It means that the reaction will favor product formation. What does that mean? It means that when you have a larger Kc value or a high value or a larger value for Kc, it means that the reaction will favor more of the product formation. And if your Kc value is small, then it will favor reactant formation. Don't forget that I told you that the equation is said to be in equilibrium when the concentration of both the reactant and product are equal. So if you have a situation where you are able to get a larger Kc value, that implies the reaction is not at equilibrium. So therefore, the reaction will favor either the reactant formation or the product formation so that to balance it. So that is why you have a smaller Kc value and then the larger Kc value. So ladies and gentlemen, I hope you will enjoy this. So let's go and let's answer another question. And I also want to add another important information. We have also a formula that we have different types of chemical equilibrium. We have two types of equilibrium constant. Types of equilibrium constant. Because sometimes I prefer while answering questions to also add information so that at least when similar or related questions are given, you will be able to answer. So we have types of equilibrium constant. So we have types of equilibrium constant. We have number one, we have Kc, which usually express in terms of concentration. In terms of concentration. And then number two, we have Kp, which usually express in terms of partial pressure. And there is a formula that shows the relationship between the Kp and Kc. This formula is Kp is equal to Kc into RT times the power delta N. This delta N, remember Kp is the partial pressure constant and this is the equilibrium constant. R is universal gas constant and then T is absolute temperature and then delta N means the number of moles of the product minus the number of moles of the reactants. So please, I want you to put this at the back of your mind. I know that we are coming to a point where we'll see similar questions that we are going to apply this formula and solve. Please, ladies and gentlemen, make sure you write down and have all this information. It will definitely help. Thank you very much and let's meet in the next video.